In this video, we're talking about function operations 7.09. Let's start with just what is function notation and how do we evaluate with functions in function notation. Function notation is what we see here, f of x. So instead of saying y equals 2x squared plus 5x minus 3, instead of using a y, we're using a f of x. That's called function notation. We can evaluate when we ask what is f of 2. We're saying what is the answer for y? What does y equal when x is 2? So that just simply means, hey, where you see an x, put a 2 and then evaluate, do the math. So wherever I see an x, I'm going to put a 2. So 2 times 2 squared plus 5 times 2 minus 3. I have to do my exponents first. 2 squared is 4, and 4 times 2 is 8, plus 5 times 2 is 10, minus 3. 8 plus 10 is 18, and 18 minus 3 is 15. So f of 2 would be equal to 15. And that would be the ordered pair 2, 15 on a graph. If we did the same thing, f of negative 2, so everywhere I see an x, I'm going to put a negative 2, and I'm going to evaluate. Make sure we do our exponents first with order of operations. So we have to square x, then multiply by 2. A negative squared means a negative times itself, which does give me a positive. So negative 2 squared is positive 4, and positive 4 times 2 is 8. And then 8 plus 5 times negative 2 is negative 10. So we have 8 plus negative 10 minus 3. 8 plus negative 10, going from left to right, is negative 2. And negative 2 minus 3 is negative 5. So by substituting negative 2 for x, we get an answer of negative 5. So f of negative 2 is equal to negative 5. Now, how are we going to apply this in our polynomials module? We're going to look at function operations. Function operations are when you take two functions and you combine them using addition, subtraction, multiplication, and division. And the way we write that is we start off with a parentheses naming the two functions and of what value follows in the next parentheses. So you can see here with each one of these examples, if we're doing f plus g, that means we're adding the f and g function of x. So we need to figure out what f of x is and add that to g of x. Where if it was f minus g, we're going to be subtracting the answer we get when we do f of x minus g of x. Same holds true for multiplication and division. So that's how we can just show that our functions are being added, subtracted, multiplied, and divided. And then we just have to apply what we know about adding, subtracting, multiplying, and dividing polynomials. So if we're doing f plus g of x, that means I need to rewrite that as f of x plus g of x. So go back and look at what they tell us the functions are for f of x and g of x. F of x is x squared plus 13. So we're going to do x squared plus 13. G of x is 5x minus 10 plus 5x minus 10. So in order to add f of x and g of x, That means I'm adding the x squared plus 13 and the 5x minus 10 because that's what those values are. Then we need to combine like terms. We don't see any other x squareds. There's only one x term. And then I have a constant of positive 13 and negative 10. So that would combine to give me positive 3. So f plus g of x is equal to x squared plus 5x plus 13. And I got that by adding the f of x function plus the g of x function. Let's look at another example there. F of x equals x squared plus 13, and g of x equals 5x minus 10. Find f times g of x. So again, I need to do the f of x function, but this time we're multiplying it by the g of x function. F of x times g of x. Our functions are already written in x format, so we really don't have anything to plug in because we already know what f of x is equal to, and we know what g of x is equal to. But this is saying they want us to multiply them. So I need to multiply x squared plus 13 times 5x minus 10. And to do that, I'm going to have to use what we know about the distributive property with a binomial times a binomial. I need to multiply x squared times everything over here, x squared times 5x minus 10, and I need to multiply the positive 13 times everything over here, positive 13 times 5x minus 10. Once I do that, I've multiplied. So let's multiply x squared times 5x. That gives me 5x cubed. X squared times negative 10 is negative 10x squared. Distribute the positive 13, and I get positive 13 times 5x, 65x, and positive 13 times negative 10, which is negative 130. Then you want to combine your like terms. And we see that we don't have any like terms because we have a cubic, a quadratic, a linear, and a constant term. So we have a polynomial with 4 terms that is the highest degree of 3. So this polynomial has a degree of 3 and can't be simplified and would be the answer we get to f times g of x. And let's look at an example with division. Here, notice the difference is they have us substituting a value instead of actually using the x. We're going to be doing f of 5 divided by g of 5. And before we can divide those, we need to know what is f of 5. And we get that by plugging in a 5 for x. So f of 5 is equal to 2 times 5, which is 10, plus 8. So f of 5 is equal to 18. So I'm going to be dividing 18 by something. Let's hope I'm not dividing 18 by 0, because then it would be undefined. When 0 is under the line, the answer is undefined. And see here, now we're doing g of 5, because the g of 5 is in the denominator. G of 5 equals 3 minus 5. 3 minus 5 is negative 2. So we're safe. We're not dividing by 0. And since g of 5 is equal to negative 2, 18 divided by negative 2 is negative 9. So I've just determined that f divided by g of 5 would be equal to negative 9.